Hi, welcome to Nomis Academy. In this video, we'll be dealing with interior angle of a polygon. We'll be dealing with interior angle of a polygon. The interior angle of a polygon is the angle formed by two adjacent sides of the polygon inside the polygon. So let's get started by the topic. Interior angle of a polygon. I said the interior angle of a polygon is the angle formed by two adjacent sides of the polygon inside the polygon. Let's take this as a polygon. So if this is a polygon, there is an angle formed inside the polygon. This is an angle, right? An angle that is formed by two adjacent sides. So this is one side adjacent to this side of the polygon, inside the polygon. So this is the interior angle. So this also part is interior angle of the polygon. This also is an interior angle of the polygon. Now we should know that there is a relationship between the side of a polygon and the angle of the polygon. Take this in thick, this in thick, this in thick, this in thick, this interior angle for an example now. So there is a relationship between a side of a polygon and the interior angle of this polygon. And what does it say? The relationship says that the sum of the interior angles in a polygon is equal to 180 multiplied by 2 subtracted from the number of sides. The relationship states that the sum, let's state it down. It states that the sum of the interior angles, the sum of the interior angles is equal to 180 multiplied by 2 subtracted from the number of side. Subtracted from the number of side. Let's say the number of side is n. So subtracted from the number of sides. So 2 subtracted from the number of sides. So this will be well written as sum of interior angle of a polygon equal to n minus 2 multiplied by 180. So where n is the number of sides, where n is the number of sides, the number of sides of the polygon, the number of sides of the polygon. So that's n. So the number of the sides has a relationship with this interior angle. So the sum of the interior angle is always equal to the number of sides divided by 2 multiplied by 180 degrees. So let's see some of them. Let's say an example. So example number 1. Let's take example number 1. Sum of interior angle of triangle. So let's say sum of interior angles of triangle. Sum of interior angles of triangle is equals to, so since triangle has how many sides now? 3. So remember the formula is n minus 2 multiplied by 180. So since the triangle has 3 minus 2 multiplied by 180, 3 minus 2 is just 1 multiplied by 180. So that is 180. So the sum of the interior angle of a triangle is 180. I believe you've heard that before, that the sum of angles in a triangle is 180. So this is how it is. So the relationship between the sides of the angle of the polygon and the angle, the interior angle of that polygon, tells that this exists in this manner. So that's why the sum of interior angles of a triangle is always 180 degrees, no matter the angle, no matter the triangle, whether isosceles triangle or scaling triangle or any other triangle. Hmm? The sum of the interior angles of a triangle is 180 degrees. So let's check for another polygon. Let's check for quadrilaterals. So interior angles, sum of interior angles of quadrilaterals. So quadrilaterals are thus have four sides, right? So no matter the case, that is 4 minus 2, be it kite, be it square, be it rectangle, parallelogram, they are all quadrilaterals. So for those quadrilaterals, it is always 4 minus 2 multiplied by 180. And you know that will be 2 multiplied by 180. And that is 360. That is why you will hear the sum of the interior angles of rectangle is 360. Yes, the sum of the four angles inside a rectangle, inside a square, inside a kite, inside a parallelogram is equal to 360 degrees. So it is a general property for all quadrilaterals. So the sum of angle inside of them. So this sum of angle is determined by the relationship the angle has with the side of the polygons. So let's check for another polygon now. So let's take an example of hexagon. So let's say the sum of interior angles of hexagon. Remember, it should be n minus 2 multiplied by 180. So since n is equals to 6, so that will be 6 minus 2 multiplied by 180. So that's 4 multiplied by 180. So 4 multiplied by 180 is 720. So the sum of the interior angles of an hexagon is 720. Once you know the sides of the polygon, subtract 2 from it and multiply it by 180, and you get to know the sum of the interior angles of that polygon. Now, to measure each of the interior angles, so we need to consider whether the polygon is a regular one or is not a regular one. If it is not a regular polygon, then each of them will be measured individually. However, if it is a regular polygon, there is a formula to calculate the angle, each angle of the polygon. So the formula to calculate, let's put that down. To measure of the interior angles, a regular polygon, because this only works for a regular polygon. So polygon, use the formula n minus 2 multiplied by 180 all divided by n. So this works for all regular polygon. And why does this work for regular polygon and does not work for irregular polygons? Definitely you know the difference between regular and irregular, and that's what makes it work for regular and does not make it for regular, and that is because all angles are equal for regular polygons. All angles are equal for regular polygon. Let's take an example. So that should be our example number 4. Example number 4 says find each interior angle of a regular decagon So solution. Since decagon is a polygon with 10 sides, remember? So decagon is a polygon with 10 sides. Then take n minus 2 multiply by 180 divided by n. So that's equal to, since our n is 10, so that will be 10 minus 2 multiplied by 180 divided by 10. So 10 minus 2 is 8 multiplied by 180 divided by 10. So we divide both sides by 0. So we are left with 18 multiplied by 8. So 8 times 8 is 64. Remember 6. 8 times 1 is 8 plus 4. Yeah, plus 6, that's 14. So 144 degrees. So each of them has an angle 144 degrees. The formula does not work for irregular polygons since the angles are not equal. Hence, each interior angles of irregular polygon would be calculated individually. I hope you understood everything I explained in this video. Bye bye. See you in the next video.